Hello again and welcome back. I was just walking to the store on garbage day here in my neighborhood, and this beauty was sitting in someone's recycle bin. So what this is, it looks like it's a new bright RC boat. It looks pretty complete. You know, the propeller spins, but there's no remote. And I think that's not really a problem because, you know, we can make our own. And so I figured I would bring this home and see if there'd be anything interesting inside. Maybe it works as is and it just needs a new remote, but the odds of me finding an old FM remote, 49.86 megahertz, are pretty low, so I'll probably end up doing some sort of Arduino-y type control scheme, which will be a good practice for my totally custom RC boat, which is coming in the near future. So yeah, this is interesting. It's got a rubber propeller. I was actually thinking of a 3D printed propeller for my own boat. It's got this nice rudder here, spring-loaded it seems. But yeah, let's see what's inside. So haven't had this open yet, but it looks like you just turn these latches. Oh, oh, the antenna needs to come out through this hole. I have to say, this plastic is like super thin, like it's incredible. And here we go. That was just the antenna hitting my light there. Okay. 4 AA batteries. Yeah, we can totally get that to work. We do have 4 AA oh. Has 4 AA batteries already inside. Really interesting. Okay. So let's see how these are arranged. Looks like there's the 2 contacts there and there. Oh, plus and minus. So let's see here. If that goes like that, the minus should be here, 6 volts across, which would make sense, but that's not the minus. This is the what the? What's going on here? Okay, so if you can see these, okay, this contact is standalone here. So that would be the negative of our pack, which is on this side. And that would bring over like this, like this, like this, to here. So this here, that should be the positive. So this is the positive, this is the negative, and I guess this would be the positive if it had its own, like a, you know, New Bright branded pack, like a rechargeable pack. Let's pop these batteries back in and see if we actually got a good set of batteries. Okay, grab my multimeter here. I'm going to be pretty incredulous if they threw this out with a fresh set of batteries. Okay, so positive here. And negative here. Holy crap, these batteries are not full charged, but still have some life in them. Okay. So I guess the only thing wrong with this is there's no remote. You know, I didn't think to dig into that recycling bin. Maybe this thing actually had a remote. There's no screw holes underneath, but there looks like there's these little clips. See if I can unclip this. Pull this deck out. Oh, it's glued though. I want to get to the electronics underneath. Okay, well, I guess we can start by removing some screws here and see where it leads us. So this is, looks like part of the trim mechanism. So to, yeah, bias it one way or another. Can take that out, but I'm not sure what that will give us. There's the antenna wire, and it looks like it's actually linked to this screw here. That's interesting. So this wire is actually part of the antenna. Yeah, this wire is part of the antenna. Quite interesting. There's a screw down there. Trying to see, this box here is screwed down as well. I feel like I probably won't need any of the control at all. I'll probably just keep the motor. Might upgrade the motor too. I have built a motor mount for the custom RC boat. Well, this might come up as a unit. Yeah, the electronics box is in there. I wonder if this is glued down, or if it'll all come up as one unit, aside from the wires, obviously. There's one screw. Is there another? I don't see another screw. Nope. Haha! I have access to nearly everything. Look at that. They've glued this box here shut. See that glue? So basically, if I want to see if the motor still works, this here, the internals, I don't think I can do anything with it. This motor might work for steering, but I think I would far rather put a servo on here. Yeah, well, I think I'm chopping this. Sorry to all those of you who had this as a childhood toy, because it is getting chopped. That's interesting. I also want to get inside this box and take a look, but first I want to see if this motor actually works. Oops, just cutting it shorter. I really should get a wire stripper. If any one of you have a suggestion for a wire stripper, I'm all ears. I have a automatic wire stripper at work, but I feel like these extremely hard coated wires with the hard PVC might not be ideal for the automatic type. Got the power supply here, gonna bump that up to full 6 volts, and then I just need some alligator clips. There's one there, one there. Connect to here and here. Flip this around, and let's see if the motor works. Put your bets in. Oh, current limited. Ooh. Interesting. The motor seems to have a dead spot because it was stuck and I spun it and it started. Interesting. Yeah, it doesn't have a lot of torque there, but sounds pretty nasty. But it does seem to work. Well, that's good. So this looks like a very nice starting off point. It's got a novel way to have the motor be separate from the rest of it. Ouch! Stabbed myself on this wire. It's got a see that? Sort of like a universal joint there. Pretty novel. I like it. I really like it. And this motor has a little bit of a heatsink coming up there. Don't know if it needs it, but why not, I guess. And I feel like if I upgrade this motor, I can use these two mounting points here and 3D print an enclosure and have a bigger motor in there. Be pretty useful. But yeah, this is very nice. Maybe we can go brushless on this. Not sure exactly how deep I want to take it. Cool. So let's take a look at the electronics box now. On-off switch here. It's a big robust switch. I'm going to try to open this, but yeah, it's glued with really hard glue. Whoops. This is very, toy grade stuff. Give me a second while I look for my opening tool from the other day. Here it is. I guess it's nonsensical to buy this and then not use it, huh? Maybe I should put it somewhere where I'm going to find it every time. Okay, well, gonna have to try to slide in between here. Not sure how well that'll work. This is pretty well glued. This glue is like shattering too. This tool is quite sharp. I really don't want to stab myself with it. And is this screwed together or just glued to the bottom? That is the question. I think it's just glued in. I doubt we'll be using this electronics board anymore. So I feel as though I can just snip these wires. 1, 2. Oh, these are still attached. Okay, this is for the plug, or the on-off switch. Can use a jumper for that. What's this for? That's another contact. Oh, there goes the steering channel. Oh, it is screwed. Wow. Very interesting. Let me see if I can zoom in a little bit closer and we'll take a closer look at what's going on here. So here we are zoomed in a little bit closer, and I'm going to see if I can kind of guide you around here. This is the first time I look at this, so stuff might be wrong, but I think overall we're going to be okay. So looking at the back, there's only one component, which is this inductor. Right? It says L2, so that's an inductor there, and it's right near that wire that went out to the antenna. So this will be the RF stuff that's happening. And if you look, you follow the traces over this way, sort of over here, it comes to this custom New Bright chip. See, it's labeled New Bright. So this is probably the RF goodness. This is the main processor, receiver, and computer. Everything is happening in here. Single chip solution for that. However, power comes in here, and there's another black wire, which is this guy, which is in parallel with this guy. So remember, there was two different contacts on the battery. So there's this contact, and then there was a spot over here, or over here, that had another contact in the tray. Well, that's for the New Bright battery, and they would be using it's in parallel, so it's one or the other. I'm not sure. I guess they just decided to have both contacts on the same side on the New Bright battery, but it's a lot harder to do that on AA's because they have to be in series, so you have to snake the connection around. Although they could have put it over here, or I don't know, maybe some models will go faster with the New Bright battery or faster with the AA's, so it's good to have them in separate locations. I don't know, but as far as I can tell, this one here, if you follow that track all the way around here, to this guy, it's all the same. So it's parallel. It works the same. Then here you have the switch between these two wires here, which come down to here. So it looks like it switches the positive over onto this pad, and then from this pad it'll go power the board. It's kind of what it looks like, or the negative. I'm not sure. I actually don't know if it's positive or negative, but it doesn't really matter. You can switch either side of it. So we got a couple of caps here, and then you come to these guys. So these two here, these two wires here, went into the steering motor. If I can just find that somewhere in this mess. Okay, you see in there, that's the shape of a motor. Probably can pop it out now. Considering I'm not keeping any of the internals, I'll keep the motors and stuff, I just won't use them. But here, I'll split that like that. Oh, there we go. Motor and a couple of gears. There's a motor. Ooh, there looks like there's some packing peanuts or something. The packing piece of styrofoam got stuck in there. Anyways, there's your motor, and those two wires are here. Now, I'm no genius, but I know that if you want to steer with a motor, you need to spin the motor forward or backwards for left or right. Like move the arm to one side for left, move it to the other side for right. So the easiest way to do that in electronics, or the best way, I'll say the best way to do that, is through a full H-bridge driver. So you use two NPN and two PNP transistors, and you switch them, two of them on in diagonal and two of them on the other way. Maybe I should make a video on H-bridges. But anyways, you take one NPN, one PNP, and it brings one side, it'll bring the power to the motor, and the other lead to ground. And when you flip it, it does the inverse, and so it brings the one lead up down to ground and the other lead to power, and that reverses the polarity of the motor, so you get forward and backwards. And I bet you anything, these four components here, the HY, HY, GY, GY, I bet you dollars to donuts, if we look these up, these are probably, one of them will be NPN and the other ones will be PNP. And the same thing will happen over here, I believe. These are the two wires going out to the main drive motor, and these are either larger transistors or they're MOSFETs, but they seem to be arranged in the same pattern. This one is D882, this one's B772, this is D882, that's B772. I bet you one is an N channel and one is a P channel if they're MOSFETs, or one is PNP and the other one's NPN if they are transistors. So pretty neat little board. Actually, I feel like they could have made it a bit smaller, but they had a footprint to work with, and I guess they made it work inside that footprint. That's pretty interesting. I like seeing manufacturing like this. It makes me feel as though one day I could probably design my own circuitry like this. I mean, it's just two H-bridge motor drivers, a little bit of RF magic, which you can get modules for these days, and a little microcontroller. So yeah, quite interesting. I think I'm going to reassemble this boat and put my own electronics in it. And if you'd like to see that, well, make sure you're subscribed to the channel then. Thanks for watching.